Everyone, Mr. Neighbor here, and today we're going to talk about motion graphs. So a lot of times we do a calculation with a formula to calculate velocity, to calculate displacement, to calculate acceleration, which we haven't talked about yet. In other cases, we can use graphs, and sometimes they're easier to look at for large periods of time so we can see the bigger picture. So you'll see a number of different graphs. One is position time graphs, another is velocity time graphs, and the last one is acceleration time graphs. So you know which one you have by looking at the labels. So here we have displacement and time. So this is a position time graph. You could call it a displacement time graph if you really wanted to. So what we're going to do is we're going to look at a couple of these and just kind of talk through what is occurring right now. So first, you notice that this person is starting at the origin right here. So what that means is they are at position 0. Their position is changing and going up so that it is at 10 meters away in 10 seconds. Or sorry, 8 meters away in 10 seconds. This line was straight, which means that the velocity was constant. They weren't speeding up, they were just walking at a steady pace. Then from time 10 to time 20, it looks like their position isn't changing. So that person isn't moving at all. So they're not moving from right here to right here. Their velocity would have to be 0 then. Then from this stretch to here, so stretch 3, it looks like their position is going down. In other words, they're moving backward. Their velocity would be negative. It's a straight line, so it's constant. So it's constantly -2 the entire time. In stretch 4, it looks like they stop. The position is no longer changing anymore. So their velocity is constant because it's a straight line, but at 0. And then for stretch 5s, it looks like they're changing their position again, and it's doing so with a straight line, so they are moving at a constant speed or velocity. All right, let's look at Woody a little bit here. So create a story that would describe what Woody is doing. So notice here we have a speed time graph. All right, so a velocity time graph, you also could think about it like that. Okay, so speed. His speed is 0 at the start, so he's not moving. And then he begins to move. It says he's going 10 meters per second at time about 5. So that's not telling you his position. His position isn't changing constantly. His position is changing rapidly because he's speeding up. Remember, this is a speed time graph. So first he was traveling at 4 meters per second. 4 meters per second right here. And then he's traveling 8 meters per second. And now he's traveling 10 meters per second. So his speed is increasing. On the position time graph, you would see something like this happen during that time for A. From A to B, it says he's still at 10 meters per second. So his velocity is constant. If you were to look at a position time graph, at that time, you would just notice a straight line that looks like this. Then from B to C, you see the speed go from 10 all the way back down to 0, meaning he's slowing down. So he was going fast, and now he's slowing down. So that will look something like this on a position time graph, to where it flattens out and his position is no longer changing. Right here we see the speed is 0, so he's not moving at all. What that means for us on a position time graph is just a flat line. The position is staying the same. Then between D and E, his speed is going from 0 up to 5. So he is speeding up. So it's not one speed this entire time. The speed is constantly changing. So when we look at that time from D to E, his speed is going from 0 up to something. And then from E to F, it's a straight line, meaning his speed isn't changing. And when his speed doesn't change, that is just a straight line on the position time graph. So all of these in green, they are position time graphs, V versus T graphs. So for these next graphs, what I want to do is just talk about what is happening to to the person that is depicted by this graph. So first, let's do the first one by looking at what labels were given. Position and time. So the position is staying the same. So this is like some person staying at a location at some distance from where he started, but they're not moving. Okay, let's think about what's happening in this situation. The position is constantly changing. So that means someone is walking away from their initial position at a constant speed. So moving, walking at 5 meters per second, and that's it. Okay. Let's look at this one. It's a position versus time graph, but it's curving. It doesn't have a constant velocity because a constant velocity is a line. So the position changes a little, then a little bit more, then more, then more, then more, then more, then more, then more. This is an example of the person speeding up. All right. If we look at this one, the position is changing a lot. Then not so much. Not so much. Less, 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 until it looks like it's hardly changing at all. This is an example of slowing down. All right, let's look at these. Oh, this looks like the one we had before. However, it's a velocity time graph. So the velocity is not changing at all, but it does have a velocity. So this means that someone's moving at a constant rate. So they are moving, but it's constant. Oops. Here we have another velocity versus time graph. This velocity is steadily increasing. So it just means that the person is speeding up. So we can see the speeding up from a velocity time graph or a position time graph. All right, here we also have a velocity versus time graph. We're starting at 20 meters per second, then we eventually get down to 2, get down to 0 right here at 4 seconds, and then we start to go negative. So if we're starting at 20 meters per second and go down to 10, that means we're slowing down. So for the first part of this, we are slowing down. Then we eventually hit 0. So we're not moving, so we're stopped. And then we have negative velocities. First at negative 10, then at negative 20, and then at negative 30. So it's like our velocity is increasing again. But because it's negative, remember, velocity is a vector. It has a direction, and that negative symbolizes that direction for us. So it was stopped, and then it turned around. Whatever this was, it turned, and then it started to speed up in that direction. So then it sped up in the opposite direction. Okay. Here we have acceleration, something we haven't talked about yet. But acceleration is a change in the velocity. This acceleration is constant, meaning it's always changing the velocity at this much. If the acceleration is constant, that means we have a graph or something that is just speeding up. Notice it's another speeding up example. We saw it in the position, the velocity, and now the acceleration graph.